So we start by looking at this quadratic formula. Once again, negative b plus or minus the square root of b squared minus 4ac all over 2a. Can we use this on any given quadratic equation? Yes. When in doubt, this is our go-to. Okay? Because once again, we proved this thing and we derived this thing from the standard form ax squared plus bx plus c. Whether or not it's factorable or not, it does not matter. Use it for any given quadratic. And the item that we're going to take a close look at today falls within the quadratic equation, and it's this part right there. Because believe it or not, there's a lot of things that this b squared minus 4ac can tell us. It can actually tell us what type of roots we're going to be looking at. Okay? So if they ask you to find the discriminant, it is simply b squared minus 4ac. Notice it's located in the square root. And notice it's right behind the plus or minus. So what we start to create is a couple of different options, or a couple of different scenarios. And this would be a nice chart to be able to put in your notes. If we say, or find out, that b squared minus 4ac happens to be greater than 0, which means we have a positive value, and we go back and look at our quadratic equation, we know that we're going to end up with this plus or minus. We know we're going to end up having two real solutions. I can take the square root of any positive value. Whether or not it's perfect, I don't know. But I do know it's going to produce two real values because the positive and the negative part of it. So if I find the discriminant and it's positive, I know I'm going to come up with two real roots. How many x-intercepts do you suppose we're going to have? 2. And you would be right. Therefore, if I go to graph this thing, I can have a parabola that looks like this with those two intersections. Is it possible it could be going downward? Yeah. We could also have this one right here. And obviously located anywhere on the x-axis. So once again, they're going to ask you to find the discriminant, b squared minus 4ac. And if that thing comes out to be positive, we know that there's going to exist two real solutions. That's good for us. We okay to move on? Or do we need some more time with the chart? Maybe I'll give you a little bit of time to continue to write some of this down. The second scenario, or the second case, is going to be when that discriminant is going to be equal to 0. What's the square root of 0 if we go back to the quadratic formula? 5, plug in the b, the a, and the c, and I get the square root of 0. What is that? 0, right? So what that does is that essentially eliminates the idea of having a plus or minus. It's not going to change, right, if I add 0 or subtract 0. So again, our two answers came from this plus or minus. That essentially goes away, so now I'm just left with one solution, correct? So Therefore, if we find the discriminant, I find that it's equal to 0, I now know I'm going to have one real solution, or one real root. Which means, how many x-intercepts will we have? 1. If that's the case, what else do we know about the graph? You brought this up yesterday when we did our activity. What did you say? Exactly. If there's only going to be one intersection point, that must mean that that vertex, that highest or lowest point, is going to be right on the x-axis. Could be that, and it could be that. An example of this would be y is equal to x minus 3 quantity squared. I know there's 2 of them. Therefore, my multiplicity is 2, given that my root is 3. Only one intercept. Okay? And the last one. We've talked about it when the discriminant is positive. We've talked about when it's 0. Now we need to talk about when it's negative. Less than 0. If it's negative, and we plug it in here, what's going to happen? Can I take the square root of a negative value? No. Even your calculator will tell you error, or syntax error, or domain error. Okay, not good. What do we create? Yeah, we end up creating a imaginary or complex root. Very good. So in terms of real roots, there aren't going to be any. 0. How many x-intercepts are there going to be? 0. And the other thing I'd like you to add for this is the idea that we have 2 complex roots. You know, we talked about multiplicity going back to this one, okay, we can use multiplicity to reason that there's only one real solution here when there should have been 2. But we got to be able to reason why there's none. Well, that's because there's 2 complex roots. If there's only one real root, does that mean there's one complex root to go along with this one? No. Okay. 2 complex roots. And if we look at some examples, notice that one's floating off in space. It's never going to touch. This one down here is never going to touch. So to me, when you start looking at that discriminative, we really start to put this quadratic equation together. There are a lot of different things that we can come to an idea on. Example number 1. I want you to take the next 5 or 10 minutes. You can work on this by yourself. You can work on it with a partner if you would. But I just want you to take a look at those 3 quadratics that I gave you. And I want you to, first of all, find the discriminant. And then I want you to provide the number of roots, the number of x-intercepts, as well as a sketch of that graph. And if you would like, you could use Desmos. But I do want you to do the algebra first to find that discriminant. For each one of these, I want b squared minus 4ac. Come up with that value, and then go back to your chart, because that's what you're going to have to do for your test. And then if you want to, pull up your laptop and you can take a look at Desmos. Why don't we take 8 or 10 minutes if we need to. Get up and move around. Start breaking down these quadratics. guess I didn't do a very good job of talking about it, but what form do we need to be in to identify A, B, and C? Yeah, standard form, set it equal to 0. A lot of you probably already assumed that. And again, if you want to look at Desmos to check these, that's fine. I want you to do the algebra first because you're going to have to do that for your test, but hopefully you're making connection to the graph then. When you are all done, rows, I need you to fill in the pieces for part A. Dalton, your row needs to fill in the pieces for part B. And Sydney's row is going to take part C. The rest of us will make sure that they are right. No, we were actually
My junior and senior year, we were so one always. B squared minus.
So yeah, it's kind of funny.
I was negative 4.
7 or 8 years.
No, I'm highly. I already know Sco's are early. I was one who said no Sco.
We played Pierce.
You can't just switch it in between chapter one. It's gotta be chapter one. Then tell me what is it? Just can't say.
Two front shorts. They're down there and it's serving.
Choose like you read a paragraph.
Just number versus zero, number versus zero.
What is the?
You two guys are done. I haven't gone that far. You don't give me a second. Got it. I'm pulling it up.
Where'd you go to use Great.
So 1, 2, 3.
I was finding myself not truly
We're at this right now. What are we doing? It's the same thing.
6x.
So we're gonna go and they're gonna transform them.
Oh, got it. Make it so. Just put like 5 and then just have your answer.
As soon as you get your answers, you can come on up.
And yeah,
0, 0, 5.
0, 0. Wait, are you doing
Wait, I'm typing.
all your grades?
Where's the H?
What I said, where are they?
You a lefty?
No, it's just like my shadows and noise.
It is tough, isn't it?
You just have papers.
That's hard.
Yeah, and it's great that you included the values there to see an intersection point. But for the rest, if you don't want to, you don't have to. Just a general schedule.
Would you? Would you? And the other ones are just would you? Wow, my nose.
Give up. Same.
Can you read
It's
them?
almost perfect.
Am I wrong?
It's November, so it's like 35 plus. Right, let's see. This is 29.
Oh, I'm sorry.
That vertex is right on the x-axis.
I feel like I'm good.
If you want to, put a big solid point there on the x-axis to emphasize that it's on there. Nice. It's alright.
I think it's 725 days. It's been like 3 years.
Alright, Dalton Ryder, Caleb or Jacob.
That took me forever.
Alright, Jacob, come on up.
What issues do you want second to do?
Middle one,
Middle.
part B.
Is,
I did.
what was it?
Have your model? Spanish Armada? His job that like what issues like
Just make sure Of course you did. Okay. I wasn't paying
Gary actually asked my brother if he'd be interested in it.
They got a lot of, I just kinda connect.
Yeah, my grandpa's.
I did.
Rotary?
You see that?
Yeah.
Got killed.
I don't care which.
I went to this.
We had a lot of land.
Why would I need that?
I should be the one that knows.
Jane, that goes well. Let's just
And
do
you can
that.
just get somewhat
and
close.
then do that. It goes further down.
There you go. That'll work. So you're looking at this right here.
I can't see, I can't tell. Oh.
What? It goes really low. You wanted me to go -18
It
down?
makes sense that it's going to be skinnier parabola because your A value is greater than 1. It's positive, so yeah. So yeah, these are number of roots and the number of intercepts that we should have came up with. But let's identify what we came up with here real quick, because this is really the nuts and bolts of the lesson. What do we get when we evaluate this? 0. What do we get when we evaluate this?
217.
217.
Oh, that's supposed to
That's all right. We'll fill it in.
Oh, yeah.
And what did we get over here?
-4.
-4. And again, I'm not so much concerned about the value. At the same time, I am if it's 0. But whether this thing is 217 or 53 or 0.5, the fact is this thing is positive. And over here, the idea is this thing's negative. And that's what's going to indicate the roots. Okay? They are going to ask you problems like that. And I'm going to have you do one more. We're going to take a look at problem F. If you would, on page 531.